Like I said, we do have some expertise in in geothermal here at the table. To give you my 1-minute background, you know, all the techniques we're talking about here are saving electrical energy and also energy in buildings, such as your furnace, which is running on gas usually. Geothermal is hitting your heating and ventilation systems and also your hot water. It can help, and air conditioning as well. And basically, you're using the energy in the ground beneath your building or on your property to either gain energy or lose energy and either heat or cool your building. It's there and it's free and it's right on site where your building is. It doesn't have to be carried to your building at all. So geothermal is a wonderful thing. I just heard Obama was talking about it yesterday in his speech. We need many methods to get to the carbon footprint we need. We couldn't get a wind person here either, so we had some calls out. Wind, solar, geothermal, energy efficiency of the building itself, so you're lowering your needs. These are all really cost-effective ways to get the job done. So that's my take on geothermal. Mariano?
I was going to say that if you want me to, I can address the use of geothermal in the sense that, very briefly.
Sure.
In the sense
you
that,
come up or sit there, either way.
Yeah, geothermal actually is a wonderful system in the sense that you get approximately 2/3 of the energy for heating a building for free. And to many of you, you will say, well, how does that happen? Because the ground temperature, as you are aware, normally is between 40 to 60 degrees. But somehow, and I could draw it how is that it works, but somehow you can draw energy from a source that it has a low temperature to heat a building. And there are many different ways for doing this. One of them, which is to using wells. If you have sufficient amount of water available, you get water passes through a mechanical system that extracts the heat from the water, which might be even at 40 or 50 degrees, and you take heat out of there, and somehow you inject it into a house at the temperature like 80, 90 degrees. One way, an analogy would be using like a transformers, that you get electricity at low voltage, and somehow you go to a transformer and you can raise it to a higher voltage. But there is that's one source, which is using wells, and then the other one is using piping that is buried into the ground up to maybe perhaps 250 feet to 300 feet. And all the piping conduct thermal energy either during the summertime, rejecting heat from the building into the ground, or during the wintertime, taking heat from the ground into the system. So,
Mr. Marino, would you say geothermal could definitely work here in the Hudson River if a pipe was actually planted there?
yes.
And then could be used to this area? Is that a possibility, or?
It is definitely is a possibility. As a matter of fact, we had a project some time ago where we wanted to do that. However, the government wouldn't allow you to do this. And the reason that the government doesn't allow you to do this is because during the, you will be at times dumping heat into the ground to dissipate it, and the marine life senses temperature, and if it gets cold, they migrate. As a matter of fact, the World Trade Center used to, didn't have a heat pump, but it used to use the river as a cooling tower. And the power plants, they used to do the same thing, get heat from the water lakes or rivers, you know, as a source. But the problem with that is the fish wouldn't migrate because, you know, they felt that the water around there was warm. And then for whatever reason, you would shut down the power plants or the systems, and then the water would cool and thousands of fish, you know, would die. So yes, you can do it. You can do it if it wouldn't be because ecologically it would have an effect in the marine life.
But you can drill. I mean, for a skyscraper, you wouldn't get too much effect from just drilling down beneath you because the skyscraper.
You can do it to the ground.
Yeah.
Oh, the ground is not a problem. But the question they raised,
right,
whether you can use water from the river directly.
Right.
In the ground, it's not really a problem because, you know, what is happening in the ground, there is a balance. During the summertime, you are dumping heat from the building into the ground, but then in the wintertime, you draw heat from the ground to heat the building. So normally there is a heat balance so that, you know, after a year, the ground doesn't really change temperature significantly. In other words, it doesn't keep building up, either reducing the temperature of the ground or increasing the temperature. But in the river, it's just directly. In other words, the fish that it will be in the vicinity of the discharge of the piping, it will not migrate. And then whenever you shut down the system.
Do you have any sense of how cost effective it is for, say, in an urban environment like this, drilling vertically, putting in geothermal piping?
Yeah, absolutely. Normally, like for instance, any time that we have an opportunity for building schools, as an example, we design geothermal system. See, the geothermal actually is not all that expensive in the sense that since you're using the ground as a source of energy, then you don't need things like boilers and heat, you know, things like this. So there is a trade-off between installing the piping on the ground and whatever, and they have a system nowadays like everything else, you know, at the beginning, they're like computers and all of that originally were expensive. But once, you know, they have a methodology for installing pipes deep into the ground, I think it's very cost effective. You know, it may have a payback of 1 to 2 years, you know, depending on the cost of the electricity. In other words, a heat pump is either the ground or electrical power. There isn't any fossil fuel that there is consumed.